Guys, so today we're going to look at how to solve systems that involve quadratics and things that are not lines. So what we're going to do is we're just going to look at visually what are some things that can happen. So the first thing we're going to look at is if we look at a line and a quadratic. So with a line and a parabola, you have a couple of options. So similar to systems with two lines, it's possible for them to not intersect and for us to have no solutions. It's also possible for that line to only touch in one spot. That one point would be called the point of tangency, and there would be one solution. It's also possible for that line to cross in two places. So this is something that was not possible when we were dealing with systems of just lines. We actually could have two possible solutions here. Now we're also going to look at cases that involve two quadratics. Well, with two quadratics, I could again have no solutions. I could again have one solution if they were to meet at the vertex. I could also have two solutions. But with parabolas, we actually have a few more cases that are possible. Because with parabolas, if you remember, we don't just have vertical parabolas, we also have horizontal parabolas. So if I were to introduce a horizontal parabola intersecting with a vertical, a few different things could happen. I could have three solutions, or I could have four solutions. So more solutions are possible than what we've considered so far. So keep that in mind just when we're solving these. The odds are you may not just have one answer, you could have more than one answer. All right, so the first thing we're going to do is just review how to solve by graphing. This is really just graphing practice. So the first one, that is a quadratic, so I need to know the vertex. The vertex is 1, -2. From the vertex, that graph has not changed from the parent function. It has not been stretched or compressed or reflected. So from the vertex, I would go right 1 and up 1, right 2 and up 4, and right 3 and up 9. Because again, it has the same pattern as the parent function. Then I would go ahead and graph my line. The line has a y-intercept of -1 and a slope of -2. And if you look, that line is only going to touch in one spot. The place where they both overlap is at 0, -1. Since that's the intersection, that is my solution. All right, looking at the next one. To graph that first quadratic, I would need to know the vertex, which is 1, 1. Typically from the vertex, the way we move, we follow the pattern of the parent function. So from the vertex, I go right 1, up 1, right 2, up 4, right 3, up 9. But because this graph has been compressed, I would instead go right 1, up 1/2, right 4, up 2, and right 3, up 4 1/2. So from the vertex, that's how I'm going to move. So right 1, up 1/2, right 2, up 2, right 3, up 4 1/2. And then I'm going to do the same thing on the other side because I have an axis of symmetry. To graph the second one has a vertex of 1, 1 as well. It's going to open down, and it's also been changed from the parent function. So instead of right 1, up 1, right 2, up 4, and right 3, up 9, it's been reflected and it's been stretched. So I would go right 1, down 2, right 2, down 8, right 3, down 18. So I'm going to follow that same pattern. So right 2, down 8, and then I'll get my other quadratic. And then you can clearly see where they intersect is just at the vertex, but we really want to get that extra practice in just to make sure we remember how to graph quadratics. All right, so now we're going to go ahead and solve some of these algebraically. So algebraically, it's going to be just like normal systems, except we're going to end up with some quadratics. So we can use either elimination or substitution, depending on what's going to be easiest for what you have. So on this first one, elimination is going to be pretty easy here, because if you notice, those y's are set to be eliminated. Now, if you use elimination, you need to be careful. If you try to eliminate x, we can't just eliminate that x, because if we did that, we're still going to have an x here and a y. What we don't want to do is eliminate an x squared or an x and still have that other term there. So if you use elimination, you need to eliminate that variable completely, including any squared version of it. So I can't do x squared without doing just the x's. So be careful with elimination. It only works well if you're going to completely get rid of that variable. So in this case it will. We're going to completely get rid of our y's. And now I have a quadratic. So when we're solving these quadratics, we probably want to see first if it'll factor, because that'll be the easiest one to solve. In this case, it doesn't factor. So I need to go to another method. So I can do completing the square or quadratic formula. So let's go ahead and use quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. Simplify what's on the inside, and you'll notice I end up with 9 minus 24 should be a negative 15. So instead of going through and writing the imaginary values for this, what we need to realize is what this tells us. There are no real solutions for x in this system. If there are no real solutions for x, that means these two graphs are not going to intersect. So since we're trying to find the intersection and that doesn't happen, we can just stop at this point and say no real solutions. We don't need to get into the complex answers. All right, let's move on to the second one. So again, elimination or substitution. I'll go ahead and use substitution because it's set up pretty easily for that. It's already solved for y, so I'm going to substitute y for y. And now I'm going to solve. So I'm going to set it equal to 0. And then this one can factor. So I'm looking at what multiplies to 4 and adds to 4, which would be 2 and 2. So I get that x equals negative 2. Once I know what x equals, I can go ahead and plug it in. So negative 8 plus 8 would be 0. So the intersection of these two graphs, there's only one place. It would be at negative 2, 0. All right, on the next one, again, we can do either elimination or substitution. I'm going to go ahead and do elimination because, again, it's set up pretty easy for it. So I can combine those and get 3x squared. The y's will cancel. And I'm left with this. And this is something that can, in fact, factor. Even if there's two terms, look to see if it can factor. Because in this case, there's a GCF, and your GCF is x. So x would factor out. I'm left with 3x plus 4. Now this is factored, so set each factor equal to 0. So x equals 0, and 3x plus 4 equals 0. Solve that second equation, and I get my two possible values for x. Now remember, since this is a system, each x does have a corresponding y as well. So I'm going to take that x value and plug it back into either of those equations. So if I plug it into the second one, then I would get 0 squared plus y equals 2. So when x equals 0, I get that y equals 2. If I take negative 4/3 and plug it in, negative 4/3 squared plus y equals 2. I need to get a common denominator, so I'll rewrite that as 18 over 9. And I get the y coordinate. Now, I can write that as an ordered pair, or I can combine them together. What you need to make sure you do, though, in your answers is you make it clear which x goes with which y. Definitively, the answer here, x equals 0, has to go with y equals 2. And x equals negative 4/3 has to go with y equals 2/9, because that's the corresponding y that goes with that x. So again, it's probably a good idea to write them as an ordered pair, because again, that makes it clear which x goes with which y. All right, then on my last one, let's go ahead and do substitution, because elimination really won't work here. I know what y is, so let's substitute y into that equation. Now remember, negative 3x plus 10 squared, we do not just square the individual terms. We actually have to do negative 3x plus 10 times negative 3x plus 10 and actually multiply this out. So that would be 9x squared minus 30x plus 100. Let's combine like terms and set it equal to 0. So 10x squared minus 60x plus 90 equals 0. Now, every term here is divisible by 10. Since we're dealing with an equation and not just an expression, I don't need to just factor out the 10. I can go ahead and divide every single term by 10, including the 0, because 0 divided by 10 is still 0. So now I have x squared minus 6x plus 9, which is much easier to factor. That factors into x minus 3 and x minus 3. So I get that x equals 3. Now I just need the corresponding y, so plug it back into your other equation. And I get y equals 1. So the intersection of those two graphs is at 3, 1. All right, so that's it. Pretty short today. Again, it's really just extra practice on solving quadratics. You need to combine either by elimination or substitution, get down to just one variable, solve that equation, and then plug it back in.